Good and welcome to this step-by-step tutorial where I'm going to show you how you create your own AI-based digital voice clone using your local computer and Piper text-to-speech. And if you do not know what Piper TTS is all about, I'm going to put a link to a video I've made about Piper TTS in general in the description box below. Piper TTS is a locally running text-to-speech service that even runs performant on small compute devices like Raspberry Pi and offers multiple languages in multiple quality levels. So there are quality levels from low, medium and high available. And by the end of this video, you will know how you create your own personal cloned voice using Piper TTS in a high-class quality model. If you like this video, please give it a thumbs up. Let me know in the comments on what you think on this topic and video in special. And please subscribe to my channel because this would really help me and this channel a lot. So thank you, and without further ado, let's go into it. Let's start by taking a look to Piper TTS documentation on GitHub. And as you can see by its URL, it's part of the Raspberry open source voice tool framework. So let's go down to the field of training your own TTS model, which is here. So let's see the training guide. So what do we need in general? We have to prepare the dataset. In this video, I'm going to use my German Thorsten-Voice dataset to train a high quality Piper TTS model from that dataset. But this will work for your personal voice, for your personal language. Then we train the voice model and we will export and finally use the exported voice model in Piper. As already mentioned, there are 3 quality levels available: low with 16,000 Hz sample rate, medium with 22, and high with also 22, but a larger voice model. And this is what I'm going to train today. Let's see what our first steps are. So we need a Linux system and should install some Python 3 development tools. For training, I'm going to use my Ubuntu long-term support. So let's see the version. So 20.04, and I've created a new and empty directory. So let's switch back to the documentation and satisfy our Python 3 development dependencies. Already installed, so nothing to install further. And let's start by cloning the actual repo. So inside the Raspberry Piper, let's hit this clone button. Git clone. So we have now cloned the Piper repository on an empty directory. Let's go into this Piper source Python directory and create a new Python virtual environment with the directory name .venv. Now you can see we have this hidden directory called venv. Now, according to documentation, let's activate our Python virtual environment by running source venv bin activate. And as you can see now by this prefix, we have this .venv name we have set as Python virtual environment. And if we run a pip list to see a list of installed Python packages inside this venv directory or venv environment, this should be pretty empty. So just pip some resources and setup tools, and according to documentation we should upgrade the Python package index tool itself and install and upgrade wheel or setup tools. So let's do this all in one because I'm so super efficient. So wheel and setup tools minus uppercase U or minus upgrade works the same way. Let's run pip list again. And as you can see, we have upgraded the Python package management itself and we have installed wheel, so this worked. Now it's time to install the Piper TTS requirements. So please make sure you are inside this subfolder source Python, because here is this file requirements.txt. Let's take a look to this one, requirements.txt. So all these packages will be installed by running the next command. So pip 3 install requirements txt. Once this is finished, let's see the pip list again. And as you can see, obviously, the list is way longer than the small default Python venv packages. And now let's go back to our documentation and run this build monotonic line shell script, or let's run this script inside the source Python directory, which I'm still inside. And the script is here already. Let's run it using the bash command. Finished. And let's make sure we have espeak ng installed, or install it in case you haven't it. So let's check the Debian package management for espeak. So as you can see, I've installed espeak ng already in version 1.50. There's one small adjustment. I've run into sometimes an issue by running the next commands, because if you take a closer look to the pip list, you can see that there's nothing Piper related, or no package in the Piper TTS namespace, however you would like to call it. One additional tip: if you run into a problem that the next steps cannot be executed because any modules are not found or missing, maybe you can run pip install -e dot. This will build a Piper TTS package itself. In my previous testing, sometimes it worked without this step, and sometimes I've run into problems. So maybe this might be a workaround if you run into problems following the next steps. So once this is finished, let's see pip list again. And now you can see a Piper train command in version 1.0.0 in this current working directory. Let's see the documentation and follow the next steps. So let's prepare our dataset. For this training, I'm going to use my Thorsten-Voice latest dataset, which is in the LJ speech file and directory structure, which is supported by Piper. So, but obviously you can use your own voice dataset, but it makes things easier if you use this famous and well-known LJ speech file and directory structure. So let's download my voice dataset. Let's go on the datasets and download the latest release. I've finished downloading my voice dataset, which is inside this folder right now. And this is in this LJ speech structure. So we have a metadata CSV with the mapping between spoken text and the actual WAV files, and this WAV subdirectory containing the actual audio files. So now we have to run the Python 3 with that model Piper train preprocess, which can take several arguments, but you can just run it plain, and it will print some default help. What's required is an input directory, so the LJ speech, your personal voice dataset, and an output directory, a language, obviously a sample rate, and a dataset format, such as LJ speech. So let's fill these values by input dir, which is the root folder of your LJ speech structure. We have the output dir. Let's use a new folder, out train. In my case, language is DE for German. A sample rate is 22,050 Hertz, and a dataset format is LJ speech. I guess there is an example printed in the documentation here. So you can run this command or adjust it to your language. So you have to pass the language code, the dataset path, the newly to created output directory, dataset format, and you can optionally say it's a single speaker and a sample rate. So let's add the single speaker for my use case. And let's run the pre-processing of this voice dataset. It will print out the number of files that are included and found in your voice dataset. So I've 83 wave recordings in my Thorsten-Voice dataset, and all of these are now processed and doing some phonetic magic, and this might, depending on your available hardware, might take some time. Process is finished, so let's take a look to the output directory that has been defined. Take a look here. And as you can see, we have a config.json file and a dataset.json.l file. And you will find these two descriptions too in Piper's documentation. And as you can see here, this is the description of a config.json file and the description of the dataset.json.l file. And once you are at this point, so we have this output training directory with the cache subdirectory with all the WAV files and some phonetic magic and the config.json and dataset.json.l, we have done all for the preparation. Now it's time to start the actual training process to create our text-to-speech model. And it's recommended that you start not directly from scratch. So you use one of the existing pre-trained models and just do fine-tuning these existing models with your personal voice dataset. And as documentation is telling, you can, or it's highly recommended, to train with a Docker file. So you can create a Docker container based on this image, and you can map your Python virtual environment and your file and directory structure as a volume inside this container. But honestly, I've done some testing, and personally, I found it more easy to use our prepared Python virtual environment that we are using here. But please let me know in the comments if I missed something here, if I'm wrong on that. But I'm going to skip this step and we'll do the actual training in our prepared environment right now. I would like to train a high quality level for my Thorsten-Voice model, so I have to choose an existing high text-to-speech model, so not the medium version. So let's nevertheless click this link, which will bring us to Hugging Face and the Raspberry project. So let's go down to the end and remove this medium, go for high, and download this checkpoint file for your low, medium, or in my case, high text-to-speech model. Let's take a look to our downloaded checkpoint, which will be the basis for fine-tuning our Thorsten-Voice high Piper TTS model. So this is this epoch 2218 step, DDLAPS, whatever. And now it's time to run the actual training command. So we'll take this one and adjust one of or some of the parameters. So let's run Python 3 with the module Piper train. And let's take the dataset directory, which is basically the output path with all the config.json and the JSON-L file and the cache phonetic adjusted WAV files in. So let's take this directory, and I'm going to use a GPU, which I will always prefer whenever it's possible. GPU-based training over CPU-based you massive performance impact. So you will reach way better performance on training using GPU than CPU. So let's take this one. Devices, I have one graphic card. Let's start with a batch size of 32, but this might depend on your available hardware. So maybe you have to decrease the value based on your available training hardware. Resume from checkpoint. This is our downloaded checkpoint file from Hugging Face. And as I would like to train a high quality level, we have to add the quality high before executing the training command. And that's all. So let's hit enter and see how training is going to start. If you encounter this problem, which I've run into previously, which is based on torch metrics, there is a workaround, which I'm going to show you now. I'm going to put a link to this GitHub issue, which is not Raspberry or Piper TTS related, but do my testing, I found this tip really helpful. So we have to downgrade the torch metrics dependencies. So first of all, let's see which version we have installed in our Python virtual environment. So make sure you are still inside your venv Python venv structure. So we have torch metrics in version 1.0.1. Recommendation here is to make a downgrade to version 0.11.4. So as I've played around with this previously, I guess this is compatible, but again, let me know in the comments if I miss something relevant here. So let's copy this one and run pip install torch metrics in the specific version 0.11.4. Let's ignore this error at the moment, and let's see if we installed the right version now, or wrong maybe. Please let me know in the comments. Torch metrics. So downgrade of version, or downgrade to version 0.11.4 successful. And let's run our training process again. This is looking way better now. And as you can see, the GPU has been found. So it's using this CUDA support and will create checkpoint files in the output directory. To keep an eye on the training progress, you can run TensorBoard, which offers a simple web UI showing some graphs, so you get an idea if your training is going to the right direction. And while training is running, let's take a closer look to the output training directory, which is in my case in this YouTube Piper out directory. And in addition to the existing cache config JSON, dataset JSON-L file, and the base epoch 2218 model that we used as starting point to fine-tune our own voice model, we now have this lightning logs folder. So let's go in this directory. And the subfolder version 1, or no, version 0 in my case, but if you run multiple test runs and training runs, this will be increased, so version 1, 2, and so on. And by this point, you can run TensorBoard. We'll do this one in a second, and you have this checkpoints subfolder. And here you have the checkpoints that are based on your current training process and will be used as input to export later on our ONNX model and use it for synthesizing in Piper TTS. But at first, let's take a look to TensorBoard so you can get an idea on the progress of your training. So a good starting point is your output directory in the subfolder lightning logs version 0 in my case. And make sure you're still in your Python virtual environment and run TensorBoard --log dir for directory equals dot for the current working directory or this path specifically. And let's add bind all. So this will be available not just on localhost port, but over your local network available. And you can specify a specific port. Default is 6006 or 6006. Let's make it 6007 in my case. Run the command. And now let's connect to our locally running TensorBoard. It's browser-based, so on the system, open port 6007. And here let's check the scalars value. And for example, the loss field. But this would go way too deep to get a deeper understanding on how to interpret these graphics. But in general, you can take a look if your training is, or the quality of your trained model is increasing by loss values getting lower. So, but that's just theory. Let's now make it a little bit more practical and try, while training process is still running, to synthesize audio phrases based on this latest checkpoint. So let's close TensorBoard as we do not need this to synthesize test audio, and go back to the Piper training documentation. To the chapter testing. Piper brings some default phrases that can be easily synthesized with a training in progress checkpoint. To get a closer understanding, let's go back some directories. So let's start in the Piper root directory, go into this etc and then in a test_sentences folder. And here you can see for all of the supported or majorly supported languages text files. So let's see the English text file, for example. A rainbow is a meteorological phenomenon that is caused by, and so on. And as I'm training my German Thorsten-Voice high Piper text-to-speech model, let's see this one in the DE, in the German language. And it's all the same phrases, but translated to each of these languages. If you would like to create own test phrases, you can go with this Piper Phonemize submodule. Let's make cat test DE for Deutsch JSON-L file. And if you take a look here, this is not just the plain text, but it's converted to the phoneme representation. So let's take it from the documentation and pipe this text content to Python module Piper train infer, copy, paste with the sample rate, copy. And now we have to specify which checkpoint we would like to train, or no, which checkpoint we would like to use for synthesizing these rainbow related test phrases. So let's specify our path from the out training directory. And by the way, is this Thorsten-Voice logo maybe a little bit annoying at this place? So maybe it's more helpful if I make it this way. Let me know in the comments if this is too annoying. So where have I been? So we need to specify the checkpoint file. So let's go with the version 0 and then checkpoints. And now I'm in epoch 2418. And we need obviously to specify an output directory where the test wave files will be synthesized or saved at. And let's save them inside the output training directory. And let's create a new folder. Let's say epoch 2408. And that's it. So let's run it and hope for the best. If you listened closely to what I've said at the beginning of this video, I said that Piper TTS is a really performant locally running text-to-speech solution, even on small compute devices like Raspberry Pi. And I'm not working on a Raspberry Pi at the moment. And as you can see, the RTF, so the real-time factor, is really not good at all. So 5, 2, 3, and so on. So this is not really representative because the training process is still running. And while training is running, my system at least does not have really huge resource compute power left over. So once the training process is finished and you will just synthesize audio, this real-time factor will be way, way faster. Let's take a look to our output directory. So this we specified here. And as you can see, we have multiple WAV files. Let's copy this one to our local system and give them a listen. Let's randomly take one in the middle and give it a listen. Der Beobachter hat die Regenwolke vor sich und die Sonne im Rücken. Okay, so with this method, you can synthesize test audio phrases with work in progress or training in progress checkpoint files. And let's say we are good to go. So this model checkpoint is good enough. So we cancel our training or use this checkpoint, and let's go to the documentation and see what's next. And this is to export a model. So we have to export this in this ONNX structure to be used later on in Piper text-to-speech. To do so, let's go in the folder with our checkpoint output. So SSD, YouTube, Piper, out, Lightning logs, version 0, checkpoints. And we can see our checkpoint file in this directory. And now let's run this example command. And again, make sure you're still in your Python virtual environment. Take this checkpoint file and let's make it Thorsten-Voice hi, for example, ONNX. And here we are. Export in this ONNX format file is finished. So let's take a look. And here we have the Thorsten-Voice hi ONNX file with a file size of just 100 megabyte. So pretty small for a text-to-speech model. And now let's add the config.json. So copy according to documentation from the out path our config.json to, let's make it the same name, Thorsten-Voice hi ONNX.json. So now we have these two files. We have the actual model and the according config.json file for our trained voice model. So, and basically that's the main part when it comes to the training. If you like that video, please give it a thumbs up. Let me know in the comment box below what you think on this topic, and please subscribe to my channel, as this would really help me and this channel a lot. Thank you all for your great support, and do not forget to check my linked video on how you use this trained model now in Piper TTS or any of the previously existing Piper TTS models. Thanks for watching, I hope you like it, and if you like, we might see us next time. Bye!